Hi future GISPs. I'm going to teach you everything that I learned to easily pass the GISP exam so that you don't have to study the 210 websites, 1,155 book pages, 1,700 Quizlet flashcards, and 291 videos and podcasts included in the GISCI recommended study materials like I did when I passed the exam. In this video, I'm going to cover database management and administration. Database management and administration is currently Section 703 of the Database Design and Management Knowledge category on the GISP exam. Let's get started. According to the GISCI's official knowledge categories, database management and administration focuses on the maintenance, performance, security, and reliability of spatial and non-spatial databases. Database administrators, or DBAs, ensure that GIS data are organized, secure, accessible, and recoverable, supporting enterprise-level GIS operations across government and industry. Let's go through the major concepts you'll need to know. The major concepts for this section you'll need to know include backup, recovery, and high availability, database security and privacy, storage capacity and planning, performance monitoring and tuning, troubleshooting and system maintenance, archiving and data retrieval, ETL, which stands for extraction, transformation, and loading, scalability and growth, business intelligence and analytics support, and cost efficiency. Let's discuss backup, recovery, and high availability. Backup and recovery ensure that critical spatial data can be restored after system failure, corruption, or disaster. Effective plans include routine scheduled backups, periodic restoration and testing, and clear documentation. High availability goes further by minimizing downtime through redundancy, using methods like data replication, clustering, automated failover, and load balancing. For example, 911 and emergency management systems often rely on continuous data replication between servers, so they remain operational even if one fails. Snapshots can also serve as point-in-time backups for quick recovery. Now let's take a look at database security and privacy. Database security safeguards data integrity, confidentiality, and controlled access. Database administrators implement authentication and authorization. Authentication is verifying user identity. Authorization is assigning privileges. Database administrators also manage user roles and audit database activity to prevent unauthorized access. Security also involves applying encryption, firewalls, and intrusion prevention systems. Strong access control ensures that the right people have the right level of access. For example, read-only access for public viewers and editing privileges for data stewards. Protecting sensitive information, such as citizen or parcel data, also aligns with privacy and compliance standards. And now let's discuss storage and capacity planning. Storage and capacity planning involve forecasting how much storage a database will need as data and users grow. Database administrators monitor disk usage, identify storage bottlenecks, and plan for scalable storage architectures. This often includes separating hot or frequently accessed data from cold or archived data. Storage and capacity planning can also involve implementing proper indexing, and using storage tiers that balance performance and cost. Understanding growth trends allows GIS administrators to prevent capacity shortfalls and maintain efficient operations as datasets expand. And now let's discuss performance monitoring and tuning. Database performance depends on efficient data access and resource utilization. Database administrators continuously monitor key metrics, such as query response times, CPU and memory use, and transaction throughput. Performance tuning includes optimizing indexes, rewriting slow queries, partitioning large datasets, and adjusting configuration parameters. Spatial databases require special tuning of spatial indexes and coordinate system references. The goal is to identify and eliminate bottlenecks so that GIS users experience fast, reliable map and data services. And now let's take a look at troubleshooting and system maintenance. Troubleshooting focuses on diagnosing and resolving issues that disrupt database operations. Common tasks include identifying causes of slow queries, resolving lock conflicts, correcting corrupted tables, or restoring failed connections. Maintenance also includes applying software patches, version upgrades, and validation routines that prevent data loss or downtime. Effective DBAs not only fix problems quickly, but also document root causes and implement preventative measures to avoid recurrence. And now let's discuss archiving and data retrieval. Archiving moves rarely used or historical data out of active databases into low-cost storage, improving performance and reducing costs. Archived data remain available for retrieval when needed. For example, restoring historical parcel boundaries for legal or planning purposes. Archiving is part of the overall data lifecycle management strategy and may include versioning, temporal storage, or cloud-based archives to meet regulatory or analytical needs. Now let's take a look at ETL. ETL stands for extraction, transformation, and loading. ETL processes are essential for integrating data from multiple sources into enterprise geodatabases. Database administrators support automated workflows that extract data from field devices or legacy systems, transform it into consistent schemas, coordinate systems, and attribute formats, and load it into production geodatabases. Database administrators must understand how to maintain ETL tools, ensure data integrity during loading, and schedule recurring data updates. Now let's take a look at scalability and growth. Scalability ensures that a database can handle increasing volumes of data and users without performance degradation. This involves planning for horizontal growth, meaning adding servers, or vertical growth, meaning upgrading resources, and implementing architectures that can scale efficiently, such as distributed databases or cloud-hosted solutions. As organizations adopt more Internet of Things devices, sensors, and imagery sources, scalability becomes critical to sustaining enterprise GIS systems. Now let's discuss business intelligence and analytics support. Modern database administrators increasingly support analytics and decision support systems. They enable GIS data integration with data warehouses, dashboards, and business intelligence tools. Optimizing data structures, indexes, and permissions ensure that analysts can run spatial queries and generate insights without compromising database performance or security. This bridges the gap between GIS data management and enterprise analytics. Now let's take a look at cost efficiency. Finally, database administrators play a key role in managing operational costs. They balance performance with storage, hardware, and licensing expenses by optimizing storage tiers, cleaning unused data, and consolidating redundant systems. Cost efficiency ensures that organizations can scale and maintain high-performance GIS environments without excessive overhead. Now you know everything that I learned about database management and administration to easily pass the GISP exam. Each of these topics, from backup strategies and data security to scalability and analytics, represents practical, real-world responsibilities of GIS database administrators. If you found this video helpful, give the video a thumbs up and subscribe so that I can keep helping people pass the GISP exam and build rewarding careers in GIS that they deserve. You can also find all this information in my book, The Ultimate GISP Exam Study Guide, available on Amazon. You can find the link to my study guide in the description below. Thanks for joining me, and congratulations in advance on passing the GISP exam.